All right, and next we want to find the area of the volume if S is revolved around the line y equals -1. So now this is going to be our new center axis of rotation. So here's our axis of rotation. That's the center of our circle. And so go all the way to the edge. That is where, this is getting a little bit ugly. That's where it's being revolved around. And so again, our big radius is always from the center of the circle to the very outside. So in this case, the big radius is going to be, it's always the top y minus the bottom y. So f of x is the top y minus the bottom y is -1. And that simplifies to f of x plus 1. So the big radius is f of x plus 1. And the little radius is from the axis of rotation until the edge of the blank where it first starts being filled in. So this is the little radius. So little radius is top y minus bottom y. So g of x is the top y of the little radius minus -1, which is g of x plus 1. So just as before, this is pi times the integral from, we already found the limits. It'll be the same limits from here to here because s is being revolved. And I've defined big R squared here, big R here, big R squared minus little r squared. This is good enough to get you full credit. Or you could type it in, you know, like you could write it like we're going to write it right here, which is y1 plus 1 squared minus y2 plus 1 squared. And this is 4.559. 4.559. Find the volume if S is revolved, and I'm going to switch over, this is getting too crowded. If S is revolved around the line y equals 2. So y equals 2 is on top of these functions, but let's just, I believe it is. Let's go ahead and verify that. Yep, there's y equals 2, so it's above. So here's y equals 2. That's our new axis of rotation where S is being revolved around it. So here's our center of rotation. We're going to go all the way to the far edge of the shaded in region. This is our big R. And the little r will be from here until the very center, like the edge of the blank spot. So, so here, big R is going to be equal to the top one minus the bottom one. So the top is y equals 2. So 2 minus g of x. And the little r is 2 minus f of x. So always top y minus bottom y. And so this is pi times the integral from, what was it before, 0.178 to 1 of big R squared minus little r squared. And that'll get us full credit. Oh, you guys couldn't see that there. Sorry, guys. So top minus bottom, that's where this is coming from. The big radius is from 2 down to g of x. The little radius, the blank part, is from 2 down to f of x. Okay, what about if R is revolved around the x-axis? I'm going to go back to this one. So R is revolved around the x-axis. So this is our center of rotation. So start at the center of rotation, go all the way to the other end of the shaded region. We're now doing R. And so now this is the top y minus the bottom y. And the top y is g of x now. So the big radius is g of x and minus 0 because the bottom y is just 0. So it's just g of x is the big R. And the little r is the edge of the blank part down to 0. And this is f of x. It's labeled right here, f of x. And so we get pi times the integral from 0.178 to 1 of big R squared minus little r squared. Again, you could do the integral of pi big R squared minus pi little r squared. That's fine. But all these things need to be well defined. Just writing this without saying what big R and little r is gets you no points. This like literally doesn't get you any points. So let's type it in. Oh wait, so it's not 0.78 to 1. This is wrong. Yikes. guys, this is now from 0 to 0.178. So from 0 to 0.178. Careful to change the limits. I was like, man. All right, so I'm going to show you what happens if you put the wrong one on top. So these limits are supposed to go from 0 to 0.178. That's right. But notice I haven't put the right one on top. I still have a f of x on top, and it'll come out negative. And so if that happens, I'm just like, oh, I need to switch it around, and also switch it around on your paper. This one must be the one that's on top. So if you get something negative, this will switch it a lot of times. This will fix it a lot of times. And so that'll just switch. You see how it just switches it from negative to positive. So if you come out with a negative answer, be like, ooh, I got to switch these around. 0.276. Okay. Find the area if R is revolved around y equals -4. So R is being revolved around y equals -4. So what is that volume? And hopefully you said this is the center of rotation. We go all the way to the end. That's the big R. And that is g of x minus, so g of x is the top part, minus -4. So g of x minus -4, which is g of x plus 4. That's big R. And the little r is from this axis of rotation until where the blank part ends. So that top y minus the bottom y, little r, is going to be f of x minus -4. So top y minus bottom y, which is f of x plus 4. I hope you guys can see this is like super similar each time. And so like once you get used to it, it's just like, oh yeah, it's the same thing each time. So this is going to be y2 plus 4. I need to put in a parentheses here. And this one is, you can just type it fresh each time if you want, but I'm not going to. And the answer is 1.903. And lastly, what if R is revolved around y equals 2? So y equals 2, you guys can't see this. Find the volume if R is revolved around y equals 2. And again, y equals 2 is up here. So this is where the axis of rotation will be. And so the big radius will be all the way to the very edge of the shaded region. This is big R. And it's top minus bottom. So R equals 2 minus f of x. And little r will be from here until the edge of the blank region. So little r will be top y, which is 2, minus bottom y, which is g of x. And so that's my big R and little r. So this is, I'll just type it again, pi math 9, 0 to 0.178 of 2 minus y1, I believe. But like, I'm not even like paying too much attention to it, because even if I like have, oops, I forgot to do 2 minus, I forgot to like put parentheses. Even if I put the wrong one on top, it'll just come out negative. And like if I choose y1 and y2 wrong, I'll just like switch it on my paper if it's like the wrong one, dx. Came out positive, so I did it the right way. So 0.538. All right, guys, this will get easier and easier with practice, as most things do. Hopefully you're feeling pretty good about this idea that if you revolve something around an axis, it's going to create cross sections that are circles. We're not actually doing anything different than we did last class. Last class we were saying if we knew the cross section, we could calculate the volume. Well, now we're saying that if you revolve something, we will know the cross section. The cross section will be a circle, and you just have to take the axis of rotation and see what circle it's going to make. If there's a blank section, it creates a disk, and you have to do the big circle minus the little circle to get the correct cross section. But it's still the same formula we had before. The volume is the integral of areas. When you revolve something, it just makes circles or disks. Now, guys, this is actually like incredibly common in manufacturing. Like when you're making something in a factory, it is so cheap and easy to make, because if you just spin something really fast, it'll cut out circles with the right radius, and you can change what that radius is as it's manufacturing. And so stuff like this water bottle is like super easy to like make by changing what the radius is to make a mold. And so it's very common that this kind of stuff exists. So hopefully you feel good. By the time you end up practicing it, I think you'll feel even better. Have a good rest of your day.